Sorry, up next is Eskindir Loha. Whenever you're ready, go ahead. And I'll be here to move your slides for you.
Okay. Can you hear me?
Try one more time.
Can you hear me?
Yes, we can hear you. Thank you.
Okay, thank you. This is Eskindir Loha, postdoctoral researcher at the University of Bergen and Michelsen Institute in Norway. And the title of my presentation is Livestock, Residual, Malaria in the state of
Eskindir, I'm sorry to interrupt you. Could you hold your microphone a little closer so we can hear you? Like the microphone.
Can you hear me better? Can you hear me?
Hold on one second.
If he's using the microphone that's on his earbuds, it actually might be better. It sounds like it's going through his computer itself.
Can you hear me?
Okay. Yeah, that's better. Thank you, Eskindir. Go ahead.
Yeah, okay. The title of my presentation is Livestock Reduced Malaria in a setup where neither long-lasting insecticidal.
Sorry, we have to pause you one more time, Eskindir.
Mm-hmm.
It's keep dropping out. You have to check his settings real quick.
Okay. Do you know how to?
If Eskindir, are you able to look under where it has the mute button for Zoom?
Yeah,
if you click the little up arrow, that's on there. You should be able to find your microphone settings and see whether it's going through your headset or through your computer. You're currently muted.
Yeah, it is microphone array. So the first one is.
So that's on your computer itself. If you can, is there another option?
Microphone. That is for the webcam. Microphone will take our audio.
Is you want the ones that are attached to your earbuds. If that gives you, because that looks like an Apple headset.
No, yeah, yes, an Apple headset, but
okay. Because you may either have to completely unplug your earbuds and speak in order for it to be clear.
Okay, should I just remove it and check louder maybe?
That's gotten worse.
Eskindir, would you prefer if we played your pre-recorded talk so we can hear it clearly? And then ask questions after?
Okay, you can.
Sorry for the technical issues.
Oh, that's great. And then so you put that, and then on there, if you hit full screen, so that actually where your mouse is, there you go. The sound isn't coming through here. I think I'm not. Yeah, because you have to share sound. You could still share screen one. Okay. Now try it.
First of all, I would like to thank.
So thanks everyone for your patience. Eskindir, what we'll do is, because the audio is a bit choppy through your headset, we'll play your MP4, which is recorded ahead of time, but we'll still engage you via question, and we'll have your video up during your talks so that people can engage directly with you.
Okay.
We'll go ahead and get started.
For this opportunity, I am Eskindir Loha, postdoctoral researcher at the University of Bergen and Chr Michelsen Institute in Norway. And the title of my presentation is Livestock Reduced Malaria in a Setup Where Neither Long-Lasting Insecticidal Nets nor Indoor Residual Spraying Did. And this is a core study. In 2019, we published an article entitled Long-Lasting Insecticidal Nets and Indoor Residual Spraying May Not Be Sufficient to Eliminate Malaria in a Low Malaria Incidence Area. And that was a result from a cluster randomized controlled trial. And just to give you some brief description about this trial before I go to the result of the current study. The trial was 2 by 2 factorial. The trial utilized 2 by 2 factorial design, and we had 44 clusters in each arm. And the total duration of follow-up was 121 weeks, with a total sample size exceeding 34,000. And in this study, we reported the overall malaria incidence to be 16.5 per 1,000 person-years of observation, and this was similar in 4 arms. So, in other words, we did not see any benefit of adding indoor residual spraying with insecticides to bed nets in comparison with using either bed net or indoor residual spray. And also this was the same for the control arm. So we speculated this could be due to residual transmission because we have studied about the human biting activities of the Anopheles species responsible for transmission of malaria in this particular setup. And we have found that more mosquito-human biting activities to occur outdoors than indoors and during early parts of the night. And we came to a conclusion that states higher outdoor malaria transmission potential in that particular area. So since the interventions that we had were targeted indoors, both bed nets, at the same time indoor residual spray with insecticides. So these interventions would not address a malaria transmission that could take place outside of the house. Right? And we have also documented that, I mean, before we started the main trial, we had a pilot study. And in this pilot study, we also tried to look at the biting habit of this mosquito, and we have found that 68% of mosquitoes caught outdoors were fed on cattle. So there is a potential in this area that cattle may play the role in transmission, and that is the main motivation of this current study that I'm presenting today for you. So I just asked myself, do prophylaxis could also be one of the explanations for the results that we obtained in the cluster randomized control trial. So for those of you who are not familiar with zooprophylaxis, it is use of animals to divert mosquito bites away from humans. In other words, other animals other than humans are dead in hostes. They will be neither infected with nor transmit malaria. So they may play a role by providing the necessary blood meal to the mosquito so that they could divert mosquito bites away from humans. So in our setup, we have documented that the mosquito feeding behavior to be zoophagic, more attracted to animals. Because as I've told you in the previous slide, 68% of the mosquito which were caught outside were fed on cattle. So the question is, did livestock ownership reduce malaria risk? So for this, I tried to look at the variables, the exposure variable being livestock ownership and outcome malaria. And with this covariates, age, sex, wealth, index, education of head of the household, the location of the household, distance of the household from vector breeding place, and also. And the strategy that I utilize to control for potential confounding is based on percent change in effect size. In other words, I run by variable analysis, livestock and the main outcome variable malaria versus livestock plus the potential confounders. So I try to look at the percentage change in the effect size. And if that percentage change exceeds 10%, then I consider that variable to be a variable that I should take into account during the main analysis. So in this graph, you can see that the Kabale is an administrative location of the household and distance from vector breeding place to be having a percentage change close to 10%. So I considered these two variables to be considered for the final analysis. And since both indicate the location of the household and distance from vector breeding site is a more important variable in this case, because when we say location of the household, it should be in relation to distance from vector breeding place. So I did not consider adjusting for both variables, rather I considered adjusting for distance from vector breeding. So I also tried to look at the causal diagram. I mean, just to play around with how variables are interrelated. So I also considered this as an input for my analysis. So coming to the statistical model, it was log binomial regression model to get the risk ratio. And this is for completed follow-ups. I mean, considering householders that completed 121 weeks of follow-up. And the sample size for this was 27,471. And I also considered parametric regression survival time model, and that would give me a rate ratio. And for this, the sample size was 71,861 person years of observation. So I used both in order to just to look at the impact of the follow-up period and the consideration of time in the analysis, so that I can get I would see that whether the results are compared, just similar. So coming to this, the livestock ownership was 88%. So out of those individuals living in a household with a livestock, so we can see that the majority had either cow or ox. And when it comes to the number of types of livestock in a household, I think slightly more than a quarter of the householders had 3 number of types of livestock. And considering the median 8 livestock in a particular household, the number of any type of livestock below 9 was just slightly less than 50%. I mean, it's almost close to 50%, and 9 up and above percent. So coming to the main result of this study, we can see that the overall risk of malaria in that particular locality was 3.7%, and 3.5% was the risk of malaria for the households living with livestock compared to 5%. I mean, for those householders living without livestock, right? So the absolute risk difference was 1.5, even though this number looks like small, but considering the overall risk of malaria, this is substantial. So in short, there was 24% reduced risk of malaria infection for the household with livestock. And I also tried to look at the dose-response relationship between livestock to human ratio and malaria risk. So I can clearly see that the reduction increased as the livestock per human ratio increased. For example, the reduction was by 25% for an average of 1.4 livestock per human, to 38% for an average of 3.6 livestock per human. Coming to the rate ratio analysis, I have seen that there is 17.1% reduced rate of developing malaria infection for the householders
with livestock. And I repeated the same kind of analysis for rate ratio, the dose response between livestock to human ratio and malaria rate. So the result was consistent. The result was consistent compared to the one that we have seen for risk. So coming to the limitation, before I make a conclusion out of this, the exposure measurement was limited to the availability and count of livestock at the beginning of the study, and we have no data to see the effect of distance of animal quarter from the human dwelling or keeping the livestock inside or outside of the human dwelling. In other words, measurement of exposure was imprecise. So I would like to consider this whenever I'm the conclusion. And I need also to take some assumptions. One, protection offered is uniform for everyone in the household, and also the household does keep the livestock throughout the study period. So this may not be the case. Unfortunately, I did not have data on that. So the conclusion, in a setup where domestication of livestock is a common practice like Ethiopia, and the predominant malaria vector tends to feed more on livestock than humans, then zooprophylaxis remains a promising strategy for malaria prevention. And also I would like to recommend on further research with precise exposure measurement. Thank you for your attention.
Okay, thank you, Eskindir. Would you like to make any further comments on your presentation before we move to questions?
No, I wish if I could present it today. This is just before rehearsal. Anyway, if there are any questions, I'm happy to take those.
Great. Well, the good news is we can hear you now. So.
Oh yeah. Okay. Wow.
Are there any questions from the audience? Peter?
Eskindir, thank you very much. We heard it well. The question is, livestock or no livestock, is it possible people with more livestock are wealthier and have better homes, more protection?
Yeah, that could also be one issue. I mean, housing, as we have heard from the previous presenter as well. We have also done some related studies with regard to improving housing, and that could also one issue. But unfortunately, I did not see that, but I need to consider that. Yeah, thank you. Yeah. Pashagu.
Marcelo?
Yeah. Those as families have pets, dogs, or cats, and if so, does it make a difference?
It could, yeah. Yeah. Actually, we just collected data on the ones that I showed you previously, but that could also be one other potential consideration. But in general, what I have learned from this exercise is that livestock ownership should be something that we need to consider in this kind of setup, especially when the Anopheles mosquito is zoophagic. Yeah.
We have an online question. What was the mosquito species distribution in the study area?
Anopheles arabiensis and Anopheles fenestis, but most dominantly we had Anopheles arabiensis. Yeah.
Are there any livestock that are more protected than others?
Pardon? Can you just repeat that?
Yeah, like which livestock is more protected?
Oh yeah. Okay. So I did not do that kind of analysis. Yeah, that's also a good point.
I have a question. Thanks, Eskindir. I really enjoyed your clear and thorough description of your methods. And I wanted to ask about your study design and the design process, because you mentioned you did a factorial design, which can be quite complicated to actually implement. And you had 40-something clusters in your factorial design, if that's right. And I just wanted to ask how the actual study planning and implementation, how you were able to do that. And maybe you could explain a little more of factorial design, because I think think it's quite complicated with the way you time the factorial design, and that's why I'm so impressed that you were able to pull it off. So yes, those are a couple disorganized questions, but thank you.
Yeah, actually, I mean, the study that I'm presenting right now is not of factorial design. I was just referring to the cluster randomized control trial we carried out. And I'm using that data set, but I just addressed this analysis according to a cohort design. So the current study that I'm presenting is not of factorial design. But for, yeah, if that would answer your question. Or are you asking me about the original study that we did?
Yeah, I think I was asking about the original study that you did. So it was a factorial design with 44 clusters with the interventions of the IRS and the bed nets and the other control measures.
Yeah, I mean, what we did was we had the main objective of that study was just to see whether using a combined intervention is better off compared to using either LA line or endoresidual spraying. That was the main question. And for that, what we did was we considered LA line and IRS as two interventions. And this would give us 4 different groups. Okay, so one group would take LA line plus IRS, the other one would take LA line only, IRS only, and the last one would not take either of the interventions. Yeah, so that was 2 by 2 factorial design.
Okay, and was that
yeah, 44 clusters for each arm.
What was the cluster size of each cluster?
The cluster size, it was around from 35 to 60 householders in each cluster.
Okay.
Yeah,
One
because okay, yeah.
And then I'll give space to others. So one thing that I thought about when designing IRS ITN combinations is, the spillover of the effect and, how you space your clusters. So I wonder how in that study design that was accounted for.
Yeah, that is a very complicated issue, actually. I mean, we thought that could also be one potential limitation of this study. In the main paper that we published, we tried to discuss that one, the spillover effect, the contamination, and so on and so forth. It has been a bit difficult for us because the clusters were naturally occurring clusters, and we tried to randomly assign the clusters to each intervention group. And that could have some potential for contamination. But the good thing is that we also did, a good entomological study along with the epidemiological study. And we, on one hand, we cannot just say that there is a kind of spillover, but on the other hand, theoretically, we would assume that one. Yeah.
Thank you.
Yeah.
Eskindir, thank you. I hope you can hear me in the back of the room, but your study shows the reduced risk of malaria associated with households that own livestock. I'm interested in your vision as to how this would be deployed as a strategy. What would your advice be to the National Malaria Control Program?
Yeah, in Ethiopia, especially in recent years, we have seen an increase in burden of malaria compared to what we had previously after the introduction of the good drugs since 2004. But we are now having some epidemics and some outbreaks in some pockets in the country. So despite Ethiopia is embarking on elimination, so in our study we have seen that only having these 2 proven interventions may not help us to achieve elimination. But in a country like Ethiopia, for example, Ethiopia is having a large population of livestock, more than 50 million cattle and so on and so forth. So I think, and the vector is Anopheles arabiensis, and we have, I think, enough evidence that this vector is affiliated or zoophagic, attracted to animals or cattle. so that the country should think about utilizing this potential, and at the same time we can accentuate, the effect of livestock by just considering cattle treatment, for example, with ivermectin or whatever available stuff. Yeah.
Wonderful. Thank you so much, Eskindir. That was a great presentation.
Okay, welcome. Thank you.
Well, there's one more question.
Sorry.
Okay.
Sorry. Great talk. I was wondering if you had any data on the amount of time the members of the household spent with the livestock, and if that impacted the protection they had from malaria.
Yeah, as a limitation, what I have tried to show you is that the exposure measurement is not precise. I should declare this. We just had information about livestock ownership at the beginning of the study, so we don't have any information whether the livestock were living with the humans within the same house, or they are outside or having a separate quarter for animals, and how they are interacting. But one very important thing is most of the time livestock in that particular locality tends to stay outdoors up to this late evening, I would say, so that we have also documented that more human biting activity of Anopheles mosquito tends to be before bedtime and early. So that having animals around would have a greater impact on diverting human bites. So that's the only thing we know. So for further research, what I'm recommending is we need to have a very good, precise, or as much as possible, better measurement of exposure, so that we can clearly see the impacts. But this would give us some good hypothesis to embark on some sort of intervention study in the future. Yeah.
Wonderful. All right. I think we'll have to cut it off there. Thank you again, Eskindir.
Okay. Thank you so much for this chance.